Hi everyone, in this segment we are going to look at staggered conformations in a little bit more detail. In a staggered conformation, there are no atoms that are eclipsing. There are no groups that are eclipsing. The dihedral angle of groups on adjacent carbons will either be 60 or 180 degrees, okay? Here we would have a 60-degree dihedral angle. Here we have a 180-degree dihedral angle. There are going to be three distinct anti-relationships that exist in a staggered conformation. Let's look at those. We could say the groups in the middle of the Newman projection are going to be anti to each other. These groups diagonally are anti to each other, and these groups diagonally are anti to each other. Three different anti-relationships. And if you were going to look at a perspective drawing about this carbon-carbon bond, the in the plane of the page bonds are a lightning bolt in shape. And when you're looking down a given carbon-carbon bond and you see that lightning bolt shape to the in the plane of the page bonds, you know you're looking at a snapshot of a staggered conformation. I'm harping on that now. It'll be really handy later in your organic career. Okay? So we're looking down a given carbon-carbon bond, down the C2-C3 bond of this compound. All right? Now, what we're going to do is look at the relative steric penalty in each of these structures, okay? What you're going to do is look at the relationships and interactions of the groups. And we have this steric notation of these two groups are gauching. These two groups are gauching. Gauche, gauche. Gauche interactions occur between two non-hydrogen groups that have a 60-degree dihedral angle. And remember, we just went over the relative steric penalty ranking. Not all gauche interactions are equivalent, okay? Now, you might identify what is the overall largest group. Here it's the ethyl group. The next largest steric groups would be your methyl groups, okay? Now, if we compare this structure to the next one, we still have the same number of gauche interactions. There are four distinct gauche interactions, okay? And in our last structure, there are also four distinct gauche interactions. Sometimes when you look at the three staggered conformations for a compound, there might be two in one structure and four in the next one, or three, okay? Here we have four, and four gauche interactions. Let's track in the middle structure and in the far right structure where that largest steric group is. Notice that on the far right, I've said that's the least stable. This is the least stable because you have the largest steric group having two gauche interactions. Whereas notice in the most stable on the far left, in the one of intermediate stability, it only has one gauche interaction. Okay, that's really going to distinguish this here. And kind of the shortcut is looking for that largest steric group and saying how many interactions does it have. Okay. So not only do we have this ethyl having two gauches, but it's gauching with a methyl group in our far right structure. It's a lot of sterics, okay? Now, the one here is a little bit more stable. The largest steric group, your ethyl group, only has one gauche interaction. And yes, we have other gauche interactions, but overall, if you were to tally these up, the one on the far right is less stable overall than the one on the far left, okay? Sorry, in the middle, the one in the middle. And the one on the far left is the most stable, okay? You have the largest steric group, your ethyl group, having one gauche interaction. And then notice here that you only have one methyl having two gauche interactions. Whereas in this structure, this methyl had two gauche interactions, one of them being with another methyl group. And the second methyl group has, as well, two gauche interactions, one of which is with your largest steric group in the structure, the ethyl group. So it can be a little visually tricky at times to compare Newman projections in their relative energy. You identify the gauches first, kind of count those up. If the numbers are equivalent in terms of the number of gauche interactions themselves, it then is important to say what types of gauche interactions do we have. For instance, just to show you how you might tally this up, in this structure we have a methyl gauche. We also have, one second here, we also have a methyl OH gauche. So we have a methyl OH gauche. We have an OH chlorine gauche. OH, chlorine gauche, and we have a chlorine ethyl gauche, chlorine ethyl. So if you're ever struggling to compare two, you can jot down what gauche interactions there are for this structure, and you can kind of cross them out, the similarities and the differences perhaps, and look for the point of difference, and then use your relative steric penalty ranking to compare and contrast.